Hello, everyone. Okay, today we're going to start talking about four-sided polygons. There's a big group of four-sided polygons that we're going to talk about: um, parallelograms, rectangles, rhombi, squares, kites, trapezoids. So, over the next few days, we're going to cover quite a few of these and look at their properties and how we might use some of those to help us solve some different things. Okay. So we're going to start off with activity 16. Today we're going to just cover parallelograms. So we're going to learn about properties of parallelograms. Now, there's a whole family of quadrilaterals, and we're going to kind of create this spreadsheet and work our way through it. So, of course, we're going to start with a quadrilateral. Okay. And quadrilaterals create parallelograms, which is what we're going to start off today. Now, as we go down, okay, they all kind of share the same properties. So a parallelogram, if it has certain properties, can also be a rectangle. Okay, so all rectangles are parallelograms. All parallelograms are quadrilaterals. So you kind of limit what you're doing as you continue to go down this list. Another type of parallelogram is a rhombus. So a rhombus isn't going to be the same as a rectangle, but a rhombus is always a parallelogram. And then if you were to combine rectangles and rhombuses together, then you would create a square. So a square has the same properties as a rectangle. It has the same properties as a rhombus. It has the same properties of a parallelogram. It's just a very specific quadrilateral. Everything kind of has to come together perfectly to be a square. And then later on, we're going to split off on both sides of the quadrilateral. We're going to talk about kites, and we're going to talk about trapezoids. So kites and trapezoids are not parallelograms. However, they are quadrilaterals. Okay. All right, so let's get some basic vocabulary out of the way. Now, I think the text box was left off naming a quadrilateral. So if you want to just click on another text box, right click copy and right click paste, copy and paste another text box up here. That way you have one more here at naming quadrilaterals. So anytime that we name quadrilaterals, we're just going to use the four vertex points. So over here in this example, and you want to go in order. Okay, so if you start at A, you want to go A, B, C, D. Could start at D and go D, C, B, A. But you always want to use these four corners, or what we call vertex points. And once you start somewhere, go in the same order all the way around. Of course, quadrilateral, just a four-sided polygon. Vertices. Vertices are just the four corners. And if I'm going too quick, just pause the video while you type it in. Okay, no big deal. The diagonals. Diagonals is the line segment that connects opposite angles. So from D to B, this is a diagonal. From A to C, that is a diagonal. Opposite sides, sides that are across from each other. So opposite sides never touch. So AD is opposite of BC. These are opposite sides. Same thing with DC this way and AB. Opposite angles are angles that are across from each other. So angle A is opposite of angle C. Angle B is opposite of angle D. Angles that are across from each other, kind of pointing towards each other. and they're definitely connected by the diagonal. And then we have consecutive angles. Consecutive angles are angles that are connected by a side, so they go in order. So A and B are consecutive, B and C are consecutive, and so on. C and D and A. Or you can go the opposite way. Consecutive angles go in order. And some of these words we've talked about, congruent. All congruent means is they have the same measure. Okay, whether it be an angle or a side. We say that they're congruent, they have the same measure. They're the same. Supplementary. When we say the word supplementary, that means angles that add up to 180 degrees. And the last word that we're going to use is bisect. Remember, bisect cuts in half, creates two equal parts. So we want to be on equal ground here and use terminology and understand the words that we're going to use in the upcoming properties. So let's start the properties. So we're just doing parallelograms today. And parallelograms have these 5 properties. There's not a whole bunch. Okay, it doesn't take much, but as long as a polygon fits these 4 properties, then we would call it a parallelogram. So the first one, opposite sides are congruent. So AD is congruent to BC. AB is congruent to DC. Opposite sides are congruent. Opposite sides are also parallel. So these opposite sides never touch each other. Opposite angles are congruent. So A is always the same measure as C. Or if B is 63 degrees, then D is 63 degrees. Consecutive angles are supplementary. So angles that are right after each other, A and B, always add up to be 180 degrees. B and C add up to be 180 degrees. So if A is 60, B would be 120. And that makes sense because if A is 60, then C has to be 60. And then if you add B and C together, they also add up to be 180. Okay? So if you know one angle, you can find all of the other angles. And the last one, the diagonals that connect, okay, that connect the corners. Diagonals bisect each other. So when I connect B and D, and then I connect A and C, these automatically bisect each other. So if I had a point here, this segment is the same as this segment. So real quick, I want to go out of this and I want to zoom in. Let's see, let me zoom in a little bit more. Zoom into this picture. Okay, I'm going to use this tool up here called the scribble tool. And I'm just going to kind of work my way out around. So opposite sides are congruent. So I'm going to take this scribble tool. And I know it doesn't look perfect, but I'm going to draw these 2 lines. Okay. That tell me that these 2 sides are always the same. Now I'm going to use it again. And again, I wish it was perfect, but we do with what we can. Some of you might do this over and over because you don't like lines that aren't perfect. AB is congruent to DC. That's what these marks mean, that they're the same, that they're congruent. Okay. Now, opposite sides are parallel. Okay. We're not going to mark those. We might mark them with arrows to show, but we'll just know that opposite sides are parallel. Opposite angles are congruent. So I'm going to start with A, kind of curve around, and you have to click the scribble tool each time. So that tells me there's one arc here, and so the opposite angle C also has one arc because these two angles are the same. And on B and D, I'm going to put 2 arcs. Again, just do the best that you can. So opposite angles are congruent to each other. And then consecutive angles, if you have 1 arc and 2 arcs on these parallelograms, you know that they add up to be 180. 1 arc and 2 arcs add up to be 180. 1 and 2 add up to be 180. And the last one, these diagonals bisect each other. So this diagonal is the same as this diagonal. And then this part is the same as this other part. So you know that these two are the same, these two are the same. All right. So that kind of helps us out on that part. I'm going to take these out so we can do them again here in a bit. All right. So let's look at the last little section. If ABCD is a parallelogram, the measure of angle A is x, the measure of angle D is 2x minus 3, then find the value of x. So let's draw this picture, and I'm just going to draw a simple parallelogram. Looks like this, and this is A, B, C, D. It doesn't matter where I start as long as I stay in the same order. We said the measure of angle A was x. The measure of angle D was 2x minus 3. So looking where these two angles are, going back to my notes, I know that consecutive angles are complementary. That means if they are right next to each other, and in this case, they're different names, but I can look at the picture and use the same thing. A and D is located in my picture here. I know that these consecutive angles add up to be 180. So angle A plus angle D equals 180. That's how I'm going to solve this. So I'm going to do x plus 2x. I'm going to combine those like terms. And then I'm just going to keep this negative 3. Okay, I need to combine the things that are the same to solve this. Now it becomes a 2-step equation. I'm going to add 3 to both sides. 3x equals 183. And then divide by 3. So x equals 61. Now, going back to my problem, I want to make sure I'm doing the right thing. But if it says find the value of x, if it said find the value of the measure of angle D, then I would plug that x back in and solve it that way. So go up here to insert image, camera. Okay, take a picture, insert, and be sure that gets put in there. Then the last one. If x, y, z, w is a parallelogram with diagonals x, z, and y, w that intersect at point A. If xa equals 3m and za equals 5m minus 4, find A. So there's a lot of information there. So it's always good. Let's draw a picture. So this time I have a parallelogram called X, Y, Z, W with diagonals X, Z and diagonals Y, W. And they intersect at point A. Just following the directions and writing it as I go. So if XA is 3M and ZA is 5M minus 4, find M. So again, going back to my picture and the way that we had it marked, we know that we know that diagonals bisect each other. So you have one mark here and one mark here. So we know that these are exactly the same. So I know that these are the same. I have one mark on each one. So 3M, they're congruent. And the word for, or the symbol for same is equals 5M minus 4. Okay. Now, there's a couple of ways we need to do this. You can either move this first. Okay. What I would do is I would try, and either way works. If I were to ask you in class, there's several ways of doing this. Since there are two things over here and one thing over here, I'm going to move this 5M over. So since this is a positive 5M, to move it over, I'm going to subtract it from both sides. Normally, I would look at the smaller one and move it over, but then that would leave nothing over here. Okay, so over here is just a negative 4, 3 minus 5, and use a calculator if you need to, negative 2M. So see, I'm limiting the steps here. Then to solve for it, I'm going to divide by negative 2. Negative 4 divided by negative 2 is just a positive 2. And all I need to find is M. So I'm going to go back and I'm going to insert by camera, take a picture, and I have two examples. So that's what we're doing today. Look at the assignment for this activity 16, parallelograms. If you have any questions, let us know.